Volume of spheres. The formula that we're going to use for volume of spheres is V equals 4/3 pi r cubed. Now, before we get too far into volume of a sphere, I want us to remember what a sphere is. It's basically a three-dimensional set of circles. And as you keep layering three-dimensional set of circles until all the surfaces touch each other, you end up with a sphere. Now, a couple of things we see. Since we're dealing with circles, I want us to remember a couple of other formulas. Area uses the formula pi r squared. Area is all of the space within one of those circles. Circumference uses the formula pi d. Circumference is the distance around one of your circles. Now, the r in our area formula represents the radius. The d in our circumference formula represents the diameter. Now, the radius in a circle is the distance from the midpoint or the center point to the edge of any part of the circle. The diameter of a circle is the line that extends from one side of the circle through the center to the other side of the circle. So we should realize that a diameter is made up of two radii. So there's a special relationship between diameter and radius. A diameter is twice the radius, or a radius is half of a diameter. All right, so we're using all of these components are going to start playing together as we work through our understanding of volume of spheres. Most importantly, we have to know the formula for volume of spheres. Volume is equal to 4/3 pi r cubed, where r again represents radius. So knowing the formula, we should be able to determine to the nearest cubic foot how much space is contained in a water walking ball, assuming that a water walking ball has a radius of 3 feet. Now, every problem you do with the volume of a sphere is going to use the formula V equals 4/3 pi r cubed. So I want to see it at the beginning of any problem that is looking for the volume of a sphere. Now we plug in what we know. V is equal to 4/3 pi times the radius, which we just determined is 3, cubed. We're going to simplify. 3 cubed, our exponents first. 3 times 3 is 9, times 3 is 27. So volume is equal to 4/3 times 27 times pi. Well, why did I rearrange the order of the 3 cubed and the pi? We rearranged the order because pi is functioning like a variable. And like any other variable, we tend to have the coefficient first, the variable last. So I'm going to move any number that can be represented like a coefficient in front of the value representing a variable. Well, let's simplify some terms. 3 goes into 3 ones, 3 goes into 27 9 times. And so now we have 4 times 9 times pi. So our volume is equal to 36 pi feet cubed. We're almost done, but we're giving an answer to the nearest cubic foot, which gives the indication that we need to round or estimate. So at this point, just like we did for area and just like we did for circumference earlier this year, we need an approximate value that represents pi. And that value is 3.14. And so we will multiply our 3.14 by the coefficient 36. And we got 36 times 3.14 gives us 113.04. Now, one of the things I do want you to do is get used to using wavy signs for your approximate answers because we're no longer ending up with exact answers once we've approximated the value of pi. So just change those over to wavies. And it said to the nearest cubic foot, so we don't need any decimals. So our final answer, volume is equal to, approximately 113 feet cubed. Let's try another. Find the exact volume of the sphere. So again, we're going to start with our volume formula. And our volume formula is V equals 4/3 pi r cubed. And we plug in what we know. I see that I have a half line represented. It's identified as 17 inches. So volume is equal to 4/3 times pi times 17 cubed. Now, I don't know anybody in the class that has memorized 17 cubed. So we're going to go ahead and give it to you. The volume is equal to 4/3 times 17 cubed, which is 4,913 times pi. All right. Well, notice in the previous problem, we were able to simplify by cross-simplifying with the 3 and the 27. This problem doesn't cross-simplify. 3 does not go into 4,913, which should give us a really good indication that no matter what we multiply it by, unless I'm multiplying by a product or a multiple of 3, and in that case, this fraction would have simplified down in the first place. I'm not going to be able to get a simplified answer for our decimal. Especially not if I want an exact solution, because the moment that I estimate or approximate or truncate anything to do with the 4/3 and the 4913, I'm ceasing to have an exact answer. So what do we do? Well, we can still multiply our numerators, multiply our denominators. So we have 4913 times 4 is going to give us 19,652. 3 times 1 is 3 pi. So our exact solution, 19,652 thirds pi inches cubed. Now, yes, you can divide 19,652 by 3 and get a repeating decimal and still represent an exact. That would look something like 6550.6. And you'll notice in your calculator you get 6666667. No, that does not mean that it eventually finally ends up as 7 being a last decimal place for some miraculous reason. No, that's the calculator rounding up that last term because it goes on forever. So I could certainly say 6,550.6 repeating pi inches cubed and still be representing an exact solution. But you're going to notice this is the more preferred answer that we're looking for in class because simplified fractions are simplified fractions. May as well stick with them. Don't waste the extra time in going down to a decimal and accidentally making a mistake. Approximately how much space is there inside the ball for the hamster? Now, it would be nice if my picture was better and we could tell that that was supposed to be an entire line across this ball. So I'm telling you that the entire line across that ball is 10 inches. And since we're dealing with radii, or half the distance across the ball for our formula, the first thing I'm going to do is mark that out and say that my radius is 5 so I don't forget. Now we can do everything we need to. Volume is equal to 4/3 pi r cubed. And so we substitute in 4/3 pi times a radius of 5 cubed. And volume is now equal to 4/3 times 125 pi. And we look at 125 and say, hey, is that divisible by 3? Not evenly. So we're going to multiply our 125 by 4, and we get the volume being equal to 500 over 3 pi inches cubed. Now this is an exact solution. But what does our problem ask for? Approximately how much? So we need an approximate solution. Volume is approximately 500 over 3 times, and the only thing that's going to have an approximation is pi, 3.14. Which means if I don't want to end up with multiple approximations, you cannot take 500, divide it by 3, and just round that answer. Because then you're going to have multiple approximations that will end up with rounding error. In order to avoid the rounding error, we will multiply. So V will be approximately 500 times 3.14 divided by 3. And notice the only thing I really did was make 3.14 a fraction so that I could multiply my numerators, multiply my denominators. So 500 times 3.14 is 1570 over 3. At this point, you can now divide by 3 and round your answer. So volume is approximately 523.3 repeating inches cubed. Identify the scale factor used to dilate the volume of the two spheres below. Now, there is more than one way to solve this particular problem. And I'm going to show you both. First, when we are comparing scale factor, we're looking for one-dimensional values. I want to compare the scale factor of the image radius to the pre-image radius. In order to do that, I need to know the radius for both, but I have not been given the radius. Actually, I've been given a volume. So when we dealt with area of circles and we dealt with circumference of circles, we learned a valuable skill. We learned how to start with the area and work backwards to identify the radius, or start with the diameter and work backwards to identify the radius. Well, we can do the same thing when we start with the volume. So, for example, we're going to start with our formula. Volume is equal to 4/3 pi r cubed. And we're going to start with the volume, which we know V to be 288 pi. So I will take that value and plug it in for V. 288 pi. Now, the only thing I have done is substitute in 288 pi for V. So we keep the rest of our formula on the opposite side of the equal sign, pi r cubed. At this point, we realize I have two variables. One, pi, but I notice that there's a pi on both sides of the equation, so we can divide by pi. 288 is equal to 4/3 r cubed. Well, our other variable was r. But now that we've gotten rid of pi, all we have left is r. So we have 4/3 r cubed. We have a coefficient multiplied by a variable to a power. Well, we can get rid of the coefficient by multiplying by the reciprocal, 3/4. What we do to one side, we have to do the other, 3/4. Value in the numerator cancels out its equivalent value in the denominator. And then we multiply 288 times 3 divided by 4. Gives us 216. All right, now we need to figure out what in the world r to the third power means. r to the third power means that I have r getting multiplied by r getting multiplied by r. We're looking for three numbers multiplied by themselves that equal 216. Now, in a typical year, by now we would be working on memorizing our perfect cubes. We've let up just a little bit this year. So we're working on our squares, and you are just now starting to learn your cubes. As such, this may not be a number that you recognize, but I do. I recognize that 6 times 6 times 6 is 216. The way we show our work for this is we say r to the third power, or r cubed, can be simplified by taking the cube root. That's going to leave simply r. What we do to one side, we have to do the other side. The cubed root of 216 is 6. Now we can represent cubed root another way, and this will take you back to your exponent laws. We could certainly say r to the third power raised to the 1/3 power. And a 1/3 power is a cubed root. So using our exponent laws, we see 3 times 1/3 gives us 1, and that's why that simplifies down to r to the first power. Well, we started off the problem saying, I need to know the pre-image radius and the image radius. And right now, we know that the pre-image radius is 6. Take just a minute and see if you can now find the image radius. All right, welcome back. So we're doing the same thing. Volume is equal to 4/3 pi r cubed. We'll plug in the value we know is 972 pi. All right, I see that pi is on both sides of the equation, so we can divide by pi. Pi over pi is 1, so that simplifies out. 972 is equal to 4/3 r cubed. Again, we'll multiply by the reciprocal to simplify out the coefficient. What we do to one side, we have to do to the other side. So 972 times 3. So 972 times 3 divided by 4 gives us 729 equals r to the third power. All right, and again, we want to take the cubed root, and we end up with a cubed root, r being equal to 9. So our image radius is 9, which simplifies to, let's see, 3 goes in that 3 times, 3 goes in that 2 times, a scale factor of 3/2. Now, that is one way to find the scale factor. We've determined that the scale factor is 3/2. There is a secondary way, and I'm fine with you using it as long as you're careful when you do so. The secondary process still deals with setting up a ratio of your image to pre-image except this time we're going to use our volume values. So 972 pi over 288 pi. We can see right away the pi's will simplify. And we can simplify 972 over 288. And that becomes 27 over 8. Now, the statement above one-dimensional length comes into play. Our volume is in 3 dimensions: a length, width, and a height. Since volume is in 3 dimensions, we generally are talking about multiplying something by something else by something else to get a 3rd dimension. And so we accomplish that by cubing values. We can take the cube root of values to go from 3-dimensional back down to 1-dimensional. So the cubed root of 27 gives us 3. The cubed root of 8 gives us 2. And lo and behold, we have ended up with the exact same scale factor much faster. Now let's just do one more. I want you to find the exact volume of the figure below. Then come back and check your answer. All right, welcome back. So volume is equal to 4/3 pi r cubed, where the volume is equal to 4/3 pi. Please be careful to say, nope, I want to know the radius is equal to 6. So I need 6 cubed. So we end up with a volume that is equal to 4/3 times 216 times pi. So let's take our 216, multiply it by 4. See if it's divisible by 3, which it is. So volume is equal to 288 pi. And we're looking for an exact solution. So we can go ahead and say feet cubed. And we're done with the problem.